Right. Good morning. Go. All right. Yes. Welcome. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I usually stream around this time each week, Saturday mornings, 10 a.m. Central Time. And I am usually working on something that is in some way related to CircuitPython. If you don't know what that is, you can learn more about the project at the main website, circuitpython.org. It is basically a version of Python that is made to run on tiny computers called microcontrollers. You can plug them into your computer with a USB cable. It shows up like a thumb drive. You can edit Python code on that thumb drive, and then when you save it, the microcontroller will run the Python code for you. And then the code itself can interface with all kinds of other electronics. So you can build projects and, props for costumes or little widgets or little computers or all kinds of things out of these different microcontrollers. There are 614 different ones that support CircuitPython right now. They come in all different shapes and sizes and capabilities. Some of them have more powerful computers. Some of them have less powerful. Some of them have lots of I/O pins. Some of them only have a few. Some of them have built-in peripherals to do specific things. Others are very general, like these Raspberry Pi Picos. So that is the really, really quick, high-level version of what CircuitPython is. It is made possible by Adafruit. This is their website, adafruit.com. They pay a team of folks, including myself, to work on the CircuitPython project and still publish all of the code for the project as open source. So all of that code is released under open source licenses. Anyone's allowed to use it or reuse it for whatever they want within those licenses. And they pay a team of folks to work on that, which is obviously really cool, I think. Being biased, as I just said, I'm one of the people that they do pay, so I am biased, but I do think that that's really cool. If you would like to help support them and CircuitPython and open source software, one of the easiest ways to do it is by purchasing hardware from them at their website, adafruit.com. So thanks to them and everyone who does support them so they can continue to support open source software and CircuitPython. So this morning, I am jumping right back into the SPA06-003 driver, which we started last night on the deep dive, and it is quite fitting. I think the quotes and the information that's here in the chat below me, messages I should say, about Endianness and where the term came from. And stuff like that, because I do think that actually factors into the thing that we are looking at most directly currently. So the very last thing I did yesterday was we started pulling out these coefficients. C0, there's a bunch of them here, so we started pulling these things out, and we have them set up as RO bits, and we were reading them and we were printing them. I have gone and ran the Arduino version of the driver, and I have also modified it to print all these values out. So these values came from the Arduino driver running on a Metro, just an old school Metro ATmega 328, I think it is. And I don't think those are the values we got from CircuitPython. I do need to switch my breakout back over here, so I don't have the camera set up today, but I am just unplugging the Stemma QT from the Metro connection. Bringing that back into the CircuitPython one here on our Feather RP2350. I'll just restart that. Yeah, so we are getting -31 for Z0, but I'm thinking we're supposed to be getting 271 positive. And the rest of them look like they are messed up as well. And I think, to bring it back to the messages in the chat, I think the key to this is actually the Endianness, or the order of the bytes. So I have two data sheets here. On the left, I have actually the BMP5X, the one we worked on the last couple of weeks. And then on the right, I have the SPA06-003. And one of the things that I have noticed today, while looking at this, I'm going to go back to page 21, which is where the register map is at. So temperature and pressure each occupy 3 registers here, 3 for pressure, 3 for temperature, and that is actually the same in the BMP. There's 3 8-byte registers for temperature, there's 3 8-byte registers for pressure, but there is a key difference, and it is, in fact, the byte order, the endianness. So in here, in the SPA06, the lowest register, in this case 0 register, and then 1 and then 2, those 3 registers make up the pressure value, but the lowest bits of the pressure value are on the last byte read. So if we were starting at the beginning, we would have read byte 1, byte 2, byte 3. In byte 3 would have been the lowest bit of the value for this pressure inside of this SPA06. In the BMP5X, though, it is actually the other way around. If I figured out that you can't shift scroll to go sideways, which is fortunate. I'm gonna try to be able to fit this without having to make it too small. Oh, does it work now? It works now. What is that? That's weird. Only when it's in half screen mode that doesn't work. That's interesting. Okay, so we'll just look at temperature. It's the same for pressure, but in this case, so 1D, 1E, 1F. So the lowest byte has the lowest bit of the temperature. 1D, 1E, 1F, that's bytes, 0, 1, and 2, or 1, 2, and 3, if you want to think of it that way. And in byte 0 or byte 1 is where we have that lowest bit, the 0 bit of the full value of the temperature. So it's opposite. So we need to use, I think, for these values, LSB first, which stands for is the first byte that we read the least significant bit. And in the BMP5X, that was true. So for temperature, the first byte we read would have been 1D, and indeed, that was the lowest byte of the value. And that defaulted to true, so we didn't have to declare it in the BMP. But now we're the other way around, so we do need to make that LSB first false. But the next thing is I have no idea how that interacts with lowest bit. We have lowest bit index within the byte at the register address. Don't need this one as much anymore. Mostly I wanted to use that one as an example of how I realized these two devices actually do opposite with regards to these values. And we just looked at pressure and temperature, these 3 byte register values. The coefficients all work the exact same way. They're not 3 bytes. Most of them are like 12 bits or 20 bits or whatever. Have here, right? So C0, for instance, is only 12 bits. It's not 3 full bytes, but it's the same deal. So 0, 10, 1, 0, that's the lowest address. Convenient. Is it in the opposite order now? Hold on. Now I have to know, actually. No, okay. This one just counts down, but the other data sheet counts up. Okay. But yeah, the first byte read is going to be the most significant byte of the value. The least significant byte of the value, or in this case, it's actually only 4 bits, not a full byte. It's going to come from the second byte that we read. In fact, it's the high 4 bits from the second byte we read. So to my reading, I think that would mean the lowest bit. So because this, well, let's first just put this as false and see if we get the same numbers out. I suspect we're not going to, though. Maybe we get lucky and it just works. It would not be luck, it would just be the person who wrote as part of register having done us a huge favor. Okay. Let's see. Ooh. Okay. Nice. We don't have to worry about that. That's awesome. So I was going down the road of like, well, I mean, truthfully, what should be changed, I think, is the docs, honestly. But I guess it's a very tricky thing to describe, I guess. The lowest bits index within the byte at the register address. So the way this says at the register address is awkward when the register width is multiples, right? Because we're reading two registers and our lowest, so this is the register address right here. And in fact, our lowest bit is not even in this register. It's in the next register down, and it is at index 4. Of course, that's not the address that we read from, but in any case, turns out that it does what we actually want in this case. And so these are all correct, and so we can just forge on ahead, pulling out the rest of the values, which is awesome. So we have C10 done. I love the names on these, by the way. We have like 0, 0, 0, 1, 0, 0, 1, 1, 1. They're like binary until here, and then it's like 2, 0, 2, 1, and 3, 0, 3, 1, and like crazy. Wow, the follower sellers are popping in early today. Look at that. Usually we wait at least till half hour, an hour into the stream. It's caught me early today. Probably not listening. We're getting banned, though. I do not wish to buy any viewers. I don't really care if anyone views. I just want to work on the stuff, and folks come and say hi. I think that's cool. If not, I think that's cool, too. All right. So we need to do 1, 1 next? Or 0, 1? 1, 0, 0, 1. So that is, I'm just going to go off of the data sheet, I think, here. So 0, 0, 0 we did. It's 20 bits. Wait, 1, 0 we did too? Okay, 1, 0 we did as well, okay. And let me just double check. All 4 of those were correct, is that right? Let me make sure we didn't, I really only looked that close at the first 2. Okay, 8, 3, 1, yeah, totally. Nice, okay. So 0, 1 is going to be next, and it is 2 full bytes? Actually, that's convenient. Is that true? It is. Nice. Okay, so that one's actually easy. I mean, it turns out they're all easy because they're register library. We just needed to know how to use it, but 0, 1, I don't want to mix this up, so I'm just going to double check again. 0, 1. That's the thing about these names. Like, I don't know if they have a meaning, like a description for what they do. I mean, I assume they're going to be used in calculating the temperature and pressure when the time comes. But the way they're named is not very, it's like very easy to get confused by. So the register is 18. In the up on those. And then that, I put 12, it's actually 16, because it's 2 bytes, 0, 1, lowest bit 0, I think that should be okay. This one is only 2 registers, it is going to be that, yep, signed. All of those are going to end up being the same, so we do one more? Let's do one more and check it, and then after that I'll do a bunch of them. 330. Nice. Yeah. Okay. Rest of these here for now, and I'll up as we go. So C11 is also 16 bits. Same. That not exist yet. In fact, what I'll do is just kind of go through and do these first. So after 11, it's 20. Maybe it's a binary pattern. Then expressed in hex. In any case, ABCD, I think, would have been perhaps nicer. If they have, like, legitimate, like, if they stand for something, if it is actually a thing in the world that could be described, it's part of the calculation, it would be better. 021 is also 16 bits. It looks like 31 is the next one that's not 16 bits and just 2 registers. Of course, we do need reference this. So we have 20 and then 21. Three zero. 1. So this is the next one that's different. This is 12 bits again, starting at 22, and it would be the 4 like the other ones were. With lowest bit 4. And then 40. Last one, and that is also 12 bits. Okay, so this one is weirder than all the rest. So this one not going to be 4, because, you know, as we saw before, 4 would have it start in the middle of the second byte that we read. We want to start at the end of the second byte we read, so I guess it would be 0. Then we need to make those this over here for a second so I can look back and forth. Screen. We had 11, 20, 21, 30, 31. Checking all the way through, we got C0, C1, 00, N. Missing 01. 01, and then 11, then 20, 21, 30, 31, 40. Okay. And the actual addresses are, so the first 4 are done. 01 is 18. 11 is 1A. 20 is 1C, 21 is 1E, 30. I need to see more of that to be sure. Well, those are the 16. All right, those are the 16-bit ones. Okay, so 30 is 20. 0, 31, 22, 40. Yeah, it's gonna be 23. Gonna read the 2 bytes, and then I guess 0 is gonna be the very, very last bit. Add 10, 0, 1. I have. Maybe I had 0, 1 and then overwrote it. This doesn't really. I think 0, 1 is the one extra one. Okay. The rest of the prints also. Twenty, 20, 30. Okay, some of them are wrong. The last one is wrong. Only the last one is wrong. Could be worse. Double check what I put. Oh, it should not be 16. Might be 12. There we go. Nice. Okay. We have all the random magic values. Now we're back in Arduino driver. Yeah, all these. So this gets called from where again? I think we were inside reset. Let's go to where it gets called. Working here, I guess. Well, we are in init, not reset. Okay, so we did reset. We checked if those are ready. We read the calibration coefficients. So it is slightly different in the Arduino driver because this is like explicitly reading them right now inside of init. And then I presume it's going to use them somewhere else when it takes a measurement. Whereas ours are like set up to be read whenever we need them. Although I do wonder, like, should we just read them once inside of the init and then store the values? Is that better than reading them every time? Something to keep in mind. It would be easy enough to add later, right? Because inside of a init, we could just grab the value from those registers and put them into normal ints or them on self. Reference those later. Okay. But it is then going on to do this. Configure for the highest precision and sample rate. Set the pressure to highest oversampling and speed. So setting, oversampling, and measure rate. Look in the BMP driver. So in the BMP driver, we just did individual constants. I didn't do like an enum construct. Whereas in the C code here, these are in fact enums. We're gonna ask the friendly text converting friend to change these constants for us. So I had to do a big list of this isn't related to that. Can you convert instance example, let's say like the example that follow. I'll do C code and we'll give it hopefully it will know to not use the example. It will know to not use the BMP name. It'll probably know. Yeah. While it's still talking, the highlights get messed up over here. So I should just use the copy button. One thing I didn't do, which yeah we can see now, is I didn't use const on these ones before. Go back in later. A different library in a different folder and not even actually the same code. I guess they're saying the values maybe were the same. I don't know, but the names are not the same, and therefore that's. Let's try PyCharm. We should have those values now. We want to go set the pressure oversampling. It looks like just 4 bits inside of the pressure config register. Already have. Pressure oversampling. I will also consult. Right. We have measurement rate and we have oversampling rate. And oversampling rate just doesn't use all of the bits. In fact, oversampling rate is this negative? I don't think that might just be. So on this one, we're actually only really looking at 3 bits. It's gonna, I mean, it's calling it 4 bits out of the register, but it doesn't ever do anything with the highest bit. It says reserved, so we don't get to use that. It doesn't seem like. So I'm just gonna set that to 3 bits instead, actually. The lowest bit is 0. It's not signed. I think we have to do least significant byte. Doesn't matter. We're only doing it's less than 1 byte, so this doesn't matter. Really, this only matters on the ones that are more than 1. So the next time this will matter is probably temperature and pressure. Register width, it's only a single byte, so that's fine. Number of bits 3, lowest bit 0. So then pressure rate is split in the order. The pressure oversampling, where this was reason. A pressure measure rate. Oversampling pressure measure. That is actually 4 bits. It is the same register, and the lowest bit is 4. Yeah. Or inside of a init. Waited for these things. Eventually I'm going to take these prints out, but the next things that happen here is where these are getting set. So oversampling to 128, measurement rate to 100. And then temperature, oversampling, same thing. Probably it's the next register. Yep. But we should check, is it the same way with the 3 bits thing going there on the other one? Pressure config. Temperature config. Yeah. Oversampling is the same thing where it's actually only using 3 bits. Okay. And then let's just oversample so it uses the same constants. Fine without you. Oh, well, I didn't change the name. Oh, redefined without usage is probably what it said. Okay. The interrupt source. FIFO false, temp ready, pressure ready. So no FIFO, and then assuming ready means like turn those on, I guess. Big register. Big register is here. Like they're coupled down. So temp register was 7, config register is 9. Script and FIFO configs. Big register. So that says we have a lot of stuff here. Every bit's a different thing. So we want to break out FIFO enabled. Temp ready. Enable temp ready interrupt. Oh, okay. Oh, hold on though, because we have FIFO here as well. Ooh, interesting. Okay, so we have FIFO enable. We have FIFO interrupt enable. We have FIFO enable. See which one. So they're doing bits 4, 5, and 6. And FIFO is bit 6, which is the interrupt one. Okay, so it's basically these three here. So let's say FIFO interrupt, temperature interrupt, and pressure interrupt. It's going to be a register, which should be a register. Yeah. Bit. So FIFO is 6. Pressure is 5. Pressure is 4. And it put FIFO to false and the other two true. I gotta run to the restroom real quick. Whoa, I'll be right back. but it says live. See. All right, set those. I guess we could try reading them back out, maybe. In fact, we should probably try reading all. One thing I found on the SPI driver, I was talking about this a little bit last night, how I need to basically get a logic analyzer in order to get back into the SPI driver stuff. What I found was in the SPI driver, when I'm writing stuff, if I just read it afterwards, it's not set to what I wrote before. I'm not sure if the writing is broken or the reading afterwards is broken. One of the two seems to be SPI on the UMP driver. But this is another device that does support both, so this will be good second thing to be able to test with. Had it twice and that's weird, it skipped pressure. Pressure. Okay, so is 128, I assume 7. Yeah, we did see that actually, because it's 111. And then I guess measure rate is 4 ones. Yeah. So those are actually working. As far as I know, I2C did not have that problem, the BMP driver. But I don't know that I did explicitly check for it until I got into SPI land. Kind of assumed if the reset write had worked and we made it to like data ready and then getting data that looked legitimate, that everything was good. Somehow on the SPI driver we got to that point where we're getting temperature and pressure data that look legitimate, as far as I know was legitimate, but the actual like configurations and stuff, the sampling rate in those not working quite right. All right, and then the last thing here inside of init is the measurement mode. Looks like is a 3 bits thing inside the measurement config register, which is 8. Measurement control here, it looks like. Both is, yeah, register first. So measurement mode, 3 bits, measure big, post bit 0. Continue both. Right, that is the end of init underscore init, which got called from all the different begin functions. Cool. So the next thing that happens in the Arduino code is what? So it goes SPY begin there, SPA begin actually, SPA begin, and then in loop it's temperature and pressure data ready, and then read temperature and read pressure. So we got 4 more things we need. We need temperature data ready, pressure data ready, and then actual temperature and actual pressure. Temperature data ready. I'm going to assume that that is a single bit. Big. Yeah, in fact, right there, 5 and 4. Big register, lowest bit. So for temperature ready, that is 5. Pressure ready, it's 4. Okay. Theoretically, those should be good. And then read temperature calls get temperature to get the raw data, and then it does call calculate temperature, which I assume is where all those C0, yeah, where all this stuff gets used. Oversample. Needs to get scaling factor. I think I'm just gonna make this a dictionary. Any reason not to just make this a dictionary? Which face? Default's weird though. How do we can't have a default? Well, default would be like it's not in there. Which it picked up on and made it into a function. Ah. Yeah. Alright, I guess we'll keep the function too. I'm gonna change the name of this though to just vector flood. Effectively just looking up based on one value, another one lookup table that style. Oh really? Oh, it does. Okay. Hmm. I mean, don't need function. I don't know why it's calling it a float anyway, though. For int. Go ahead, float. Why it did that. Do we need this? I mean, we could just always do this, right? And this is like like I don't think it's meant to be part of the API really. I think this is just no, I think this where we need. All right. So we unwisely started cutting code before I really have any. All right. So we want a property for accessing the temperature. We want a descriptor, internal variable, private temperature, which is going to be the 24 bits. So we will need a lot of things here. We will need the correct address, lowest bit, 0, the register width, 3, false, sign, probably. Pressure data. The pressure data contains 24 bits. Choose complement. Measure value. If the FIFO is enabled, it will contain the FIFO. Otherwise, it contains measurement results and will not be cleared after read. Okay. The highest byte of the 3 bytes measured pressure value. Byte 2. Okay, so byte 2, byte 1, byte 3. Right. Okay. So the address in our world is 0 for the pressure, but I'm doing temperature first, so it's actually 3. We probably, I guess, have like a big. Ooh. Yeah, byte 2. Byte 2 is register 3. Temperature byte 2 is register 3. Yeah. So then here, this is not just oversample, it's what? Temperature oversampling. And it put this into a variable called KT. Float KT. It does call it a float right there. Like it's returning ints, but fine. Matter, I don't think. Convert to a signed 32-bit. Okay, so that right, yeah. That's raw temperature. So that's the 24-bit value that came from there. I don't think we need to do this really. I think our Python integer is already 32 bits. We already read it as an integer, I think. We should. We do need the raw value though. temperature. And it should just be signed already because we did signed here. Calculate the scaled measurement result. Calculate the compensated temperature. Return the compensated temperature. It's like splitting up the comment into multiple lines. Understand. Still messed it up. Did it? Maybe it didn't. It did. This is useless. I want these to reference for a minute so that I can not have to bounce back and forth and instead just look at one thing. Okay, so the raw temp raw SC is, I don't know if this matter for us. Well, I called mine different, but I guess we'll do this over KT. So that's a float. Yeah, okay. I think we don't need this because it's already going to be a float because of division. Calculate the compensated. So temp comp equals, I'm going to go without the float and see how far we get. So C0, that is an int. Multiply it by 0.5f, which is going to make it into a float. So I don't think we need to be casting like that. It is not just C0 though, it's self.coefficient. I don't know. (0.5f) is not a thing here. Float of self.coefficient C1 times temp raw SC. Okay. Even looked at CodePy today. Assume that's going to be in Celsius. They were actually doing this. If SPA dot and they also had a sleep whether or not the data was ready. 10 milliseconds. All right. We get temperatures that look real. No. Is there any use in making this an actual float first? That thing really. We are getting data ready, which is good. Okay, well, let's look at this. Is that Kelvin? No, because this is like we at 28 208 8960, which was because we had the oversampling set to that. Okay. Fine. So then we would have gotten that and divided it. Calculate the scaled measure. SC is scaled, okay. We know the value there because it's getting returned. And they're fine. Unless they have changed. Oh, well, for one thing, we're not writing the temperature. I don't necessarily think that should matter because we didn't try to set it. That doesn't seem to make a difference. We have 24 bits because 8 times 3 is 24. We are looking at the temperature byte 2 register as the first one, the lowest index register that we're going to read. The lowest bit is 0, because as we saw before, kind of like travels down to the last one you read. That part kind of seems okay. Bit 0, register with 3. The significant bit first false. Signed true. And it did say signed. Well, it said whose complement. Does that mean signed? Well, I think that means we need to have signed true because of the way here. That. Go feed the cat. Okay. I think the easiest way to troubleshoot this is gonna be to go back to doing it here in the Arduino driver. So grab 2 of these and learned for future Tim. Breakout is super cheap. Because then I could have one plugged into the Arduino device and one plugged into the CircuitPython device. Okay, so the first temperature reading was wrong, but then after that, it's basically looking correct. I think 25, that's like about room temperature. It was relying on this println here at the very, very end, so it's just going all wide, but fine. So that one comes out correct. And I think the next thing we do is we dive into here. And we know the value getting returned because it also gets printed. That is that is open to the library that's in the Arduino libraries folder. So by modifying that and then rerunning here, we should be getting the one I just modified. Okay, I didn't put like a colon or a space or anything, so it's a little wonky looking, but definitely different, right? That's 808. I really like in CircuitPython the ability to control C. I could just easily stop this. All right, KT is good. Temp raw signed is different, which then makes temp raw scale different. Presume which makes the rest of it different. Temp raw signed is wrong. Which is just coming from the register. Hmm. Register E. We're reading 3 registers. Getting least significant byte first false. The most significant byte comes first. So I'm kind of assuming that the lowest bit is wrong for this. But that's very bizarre, since on the 12-bit ones, and the 16-bit ones, that worked correctly. 16-bit ones especially. Those were coefficients, so they're not in this table, they're down below. Those are the same way, though, to be clear, right? I didn't flip those in my head or anything. Those 16-bit ones like this. So like C10, we pointed it at address 16. We told it, well, C10 is 20 bits. Hold on. Let's do C01, actually. "16 bits." We pointed it at 18, which is its most significant byte, the lowest register address. We told it the width was, told it lowest bit 0. Told it the register width was 2. We had least significant byte first false, and we had signed true. And that all worked fine. So why does temperature not work? "24 bits because it's 3 bytes. 8 times 3 is 24. 3 width. Do we get the wrong value? So raw temp got passed in here. Maybe the conversion, sign. Maybe that conversion to int32 actually did do something? So 2-bit int unsigned. Right, and then it converted it to a signed int. Yeah. So it starts at B2, reads 3 bytes, most significant byte first. Reads the data, does the 2's complement thing, turns it. Is that the 2's complement thing? Do we need to, maybe we need to be doing this. Is this the 2's complement thing or not? I'm more hesitant to use the chatbot here for something like this, but we'll at least see what it says. Okay. Check the signed bit. And so it's actually casting it to an int 16. No, it isn't 32. Okay. I don't know where the 16 in my head. Yeah, when it gets convert here, I guess it gets actually signed. So let me print it before we convert it. Maybe we have done some part of that wrong. Let's just say raw temp. No, those are the same. And in this one, it's different because we didn't pass it into the function. We're just reading it off of the register descriptor. We know it's wrong. Turn signed false. I think it needs to be true. Even if this happens to work, like, I think it's really Still big value. Not quite double, but it's close to double. And KT being afloat doesn't matter, because we're legit just getting the wrong value for the temperature. I not really know what to do with that. So these don't use the names, but I think it's 24 bits. Register address, lowest bit 0, register width 3. It has to be something to do with... It has to be, I think, something to do with a weird interaction in these, but I do not understand what it could be. Because, like, the 16-bit ones here are basically the same way. It's going crazy. "21 characters. 4 leading zeros." That's what we're getting. This is what we're wanting. That is only 20 characters. That makes it 24. So no, it's not quite the same because that's 3 zeros. Like, does it? Hmm. We were doing so good. Um, are these like out of order? Huh? I don't have any of the patterns of this. I'm baffled. I basically have nothing. I mean, I guess we could forge ahead to pressure if we get legitimate pressure values. And not have more bits than registered size. Have more bits. And tell me how many's highlighted there. There's that. Temperature register address 3. The mask is this. Thing is 24 ones. Hmm. We're not getting negatives, so presumably we're not in here. Um, I'm baffled. I don't really know what to try. I'm gonna try this with bytes. I don't really want to do that. Because that kind of wrecks being able to get the spy driver to work easily. Um, so we are little Indian, but the problem is there's no 3 byte number, right? And we can't do int because that's gonna read 4 bytes. So like really what I want to get is a byte string. I mean really what I want is for the RW bits to work, for me to understand why they don't work. I don't know how to use this. Oh, 10S, okay. Okay. What's the difference between S and P? Pascal string. Alright, I'm gonna try to read bytes. I guess 3S. The record state that I don't like it. I don't think it would be array because we have one. Like we have 3 bytes, but I'm only trying to read one value. What now? The address and the struct format only. Okay. We will see what. Known format. Okay, so we do have 3 bytes. How do I convert that to, say, an int? Convert byte string to int. From bytes, byte order. Int dot from bytes. What I'm gonna do is temp bytes. Sure. Print bytes. Signed is gonna be int dot from bytes. Byte order is in fact, it's doing the oscillating thing that it was doing before when I had set sign to false. Sure if that works like that. Python. We would need to make it a for first. Get like 8 million. Hmm. We did get two much bigger numbers the first time, which we did see in Arduino as well. With the first temperature read, it's not here anymore. The first temperature read was actually high. Of course, I don't know if a big number here results in a larger temperature or not. I might be basically about out of steam. I don't really know what to do next. Well, does this have least significant? Does not have least significant bit first. Byte first. Well, it would be in the struct though. Use this actually. So it should be greater than 3s. Going crazy. Okay. That failed. Hmm. Oh, I did the wrong one. Too little. Did do little. Oh, but I wrong one on the struct. I mean, this sad part of this like doesn't even really solve the root problem. This was all an exercise in like, do these even come out the same? Still no. Okay. So that I also don't really get. Like, it doesn't really. I'm not sure if it helps us solve the real problem of we're getting the wrong temperature out of the register or not, but it maybe sheds a little bit of light on it, maybe, but I'm not sure. So I think these should be equivalent, basically. This is reading 24 bits, little Indian, least significant bit first false. Signed, so it's doing the two's complement thing. Starting there, lowest bit 0, register width 3. All that should be the same. Temperature is reading little Indian, 3 bytes into a byte string, same register. We take the 3 bytes. We from bytes. Is this like a double conversion? Well, we know that. I mean, we know that. I mean, presumably these would offset each other, I guess, and we already know it didn't work the other way. Okay, never mind. So we get the same value now. That's a good start. Kind of. I don't even know if it's a good start. It makes it less confusing, I guess. We're at least baseline. We're at least baseline getting this same thing now. So those are equivalent. And it's not some kind of like. And we're still basically larger than. Still larger than what we're expecting. This has 4 leading zeros, and we only got 3 leading zeros there. But this does look a lot closer to this. Does it? Not really. Kinda little tiny bit here, 100, bunch of ones, but it's differs there. And obviously it differs up here. There's quite a bit of difference there. There's less ones. I will say I'm confused about why this the other way and then here on little. Shouldn't, if those are flopped, it should just do the same thing. I thought, like, if this was little and up here it was big, then I would have thought you got the same value as if this was big and down there it was little. Or other way around. I don't know if I might have just did them backwards, but does not actually seem to be the case though. Very odd. I guess I don't know why that would be different. But in any case, we're not getting the right value. Getting the same value now, which is good, but it's still not correct. Yeah, and I am out of troubleshooting ideas for right now. So I'm gonna head out for the day. Thank you to anyone and everyone who has watched along. I hope you have a good rest of your weekend. I should be back next week, I believe, for Deep Dive on Friday afternoon. Should be back to not tomorrow, but next Saturday at the same time as this week, 10 a.m. Central Time, for some more CircuitPython action. I will see you then, and until then, bid you farewell. Have a good day, good weekend, good week, all that stuff. See you later.